All right, Workplace 20. So we are just coming back and we're going to go through our next unit in the financial services unit or the financial banking unit. And this section is going to be all about simple and compound interest. So if you've ever heard about the old saying about like, would you rather get $1 a day and just keep getting $1 a day, or would you rather get a penny a day and have a double day after day after day for an allowance, right? And so it really comes down to whether or not simple interest or compound interest is better. A lot of the time simple interest could get used with if you just borrow $50 off a grandparent or something like that and they want to charge you interest, well, they're going to say like, okay, I'm going to charge you 10% interest. Well, then they can just calculate it in a very simple fashion, whereas banks and most financial institutions are going to charge you compound interest. So we're going to go through a little bit of both here so that you have an understanding of how to calculate these. So, simple interest is paid only on the initial amount deposited or the amount borrowed, called the principal. So, some different terminology. Principal is how much you borrowed. So, if you borrowed $50 from the grandpa, that's your principal. Your simple interest is going to be the amount that, in addition to paying back the principal, you're going to have to pay back interest. The term, so how long you have to pay back the amount. And those are the three things that you need for simple interest calculations. So there's two formulas here. I stands for interest. The P stands for principal. The R stands for the rate or interest rate. Now, if it's like 2%, well, you're going to calculate that as 0.02. Okay? So you always take 2 divided by 100 to get it as a decimal. So you want to change rate or R into a decimal. T stands for term. So how many years the investment will be in there. Another formula here I just want you to notice is A stands for the final value of the investment. So if you invest $100 into something, into an investment, what is that amount going to be? What is your principal plus the interest? So what is it all going to add up to in the end? So your $100 plus the amount you earn in interest is going to be your final amount. Okay, just going to move around here. So let's get into some examples of calculating that. There is an example there. So I won't do that one. We are going to move ahead. And I'm just going to look at a couple of things on example 1, which is, you can find that on page 292. Okay, so at the bottom here, we're going to look at, they give you 3 items. Those are the 3 things that you need in calculating simple interest. So remember, your formula is just interest, principal times rate times term. So we're just going to go ahead and take $2,000. We could put the decimals, don't need to. Change that rate to a decimal value. And your term is just 1 year. So multiply that together and I get $50. Okay, so in the end, if you wanted to know what the investment would be worth in total, it'd be the $2,000 plus the 50, so $2,050 would be what the person could take out after 1 year of keeping that investment locked in. Now, a couple other little things that I do want to just draw your attention to. It does say, well, what happens to the amount of interest earned when the principal and the term stay the same, but the rate doubles? So just try that out for a quick second. Your interest, if I kept my principal, which in that last example we used $2,000, and I kept my term, which was 1 year, the same, but my rate doubles. So instead of my rate being 2.5%, I'm going to make it 5%. So doubling that amount times the 1. Well, now it's going to be $100. So the interest will double. So you double the interest rate, meaning that your interest in the end is going to double. Now, next part it says, what happens to the amount of interest earned if the principal and the rate stay the same, but the term doubles? So instead of 1 year, now again, we're just going back to the 2.5%, but now I'm going 2 years. Well, multiplying those two together, that just becomes the 0.05. Then multiply all of that out, I get $100 again. So the interest would double. So, and then if I doubled my principal but kept my rate and my term the same, your interest is going to double. So you just change one factor in all of that and your interest will double. Okay, some more terminology, things that you're going to want to read through to fully understand this. So, compound interest. This is a type of interest that is calculated on the principal plus any other interest earned in the past. So, take for example the idea if you get a interest charged or interest added on to a principal amount, but then you kind of calculate all of that to be like principal. So if after 1 year you now, instead of having $2,000, you now have $2,050, well, $2,050 becomes your new principal. And so the following time when I calculate my interest on that $2,050, it's going to be more than just $50. It's going to be a little bit more. And so it does start to add up faster. So banks really like to use the compound interest because it does benefit them in the long run. And as well as an investor, investing and getting compound interest is going to add up quicker. So compounding interest is going to be a great way to go. Now, there are different ways that you can compound. So there's different compounding periods. So that's the number of times in a year that the interest charges would get calculated, and your principal, the amount of your principal kind of changes to reflect that. So often in investments, you will get quarterly amounts, which are 4 times. Quarterly is 4 times a year, or 4 compounding periods every 3 months. Sometimes you might see semi-annually, which is 2 compounding times per year, so every 6 months. Things like credit cards and things like that, they could do compounding daily, so 365 times a year, or monthly compounding. So always have a look at how many times things are compounding. The more times that they compound in a year, the faster that interest is going to grow. Alright, so then there's some very important formulas to keep track of. This is the compounding interest formula. This is one that not a bad idea to just get used to, familiar with, how to use it. I will grab my calculator and show you how to use it on the calculator as well. And we can go through some of that. So I guess I'll just kind of run through here. So your A stands for like your total amount in the end, what the actual amount will be worth in the end. So that's principal plus any interest accumulated over time. P stands for your principal, how much you invest, so the dollar amount that gets invested. 1 is just 1. There's no fancy, it's not an L or anything like that. It's just a 1. Then you add the rate, the interest rate. Always change that to a decimal like we did before. N is going to be any compounding time. So if it's calculated quarterly, you're going to put a 4 where the N is. And then up here is an exponent, which is a multiplication of two values. So T is going to be your number of years, and N is going to be how many times it's compounded. So in that year. So if it's compounded quarterly for 5 years, your exponent is going to be 4 times 5, which is 20. So how do you calculate something times itself 20 times? Well, you need an exponent button on your calculator, okay? So let's get into some of those calculations. If you have any trouble finding some of these buttons on your calculators, you can always reach out to me and I could show you very quickly. But I'll kind of go through what it looks like on my phone as well. Alright, so I am turning to page 296 and I'm just going to run through example 6 with you down here. Just one moment. Alright, so just to help us out, I'm just going to copy down that formula, compound interest formula, so 1 plus R over N and T. Okay, so I have that one's memorized, it's ingrained in the brain. And so we've got $8,000 is our principal, so calculate how much interest you would earn on a deposit of $8,000 invested at 2.5% compounded annually for 5 years. So say you come out of high school and you happen to get an $8,000 inheritance and you go ahead and you invest it. What is that going to be worth after 5 years? Okay, so let's put some of that into practice. So $8,000, 1 plus your interest rate is 0.025 divided by, it's compounded annually, which means once. So your N is going to equal 1. And then your exponent is just 1 times the number of years, so 1 times 5. Up there in the corner. Alright, so let's go ahead and calculate some of that. So I'm just going to go 0.025 divided by 1. That is still just 0.025. Then I add that. I have to do things in an order of operations type of way. So always start with this division, then add it to 1, and then raise it to the exponent. I might want to do this multiplication really quickly before I start entering things into my calculator. And I'll just bring out my calculator here. Sorry, it's got some blur to it. It's not a very nice screen. So that I can see that a little bit. Not that I need to make this calculation, but I'll show you anyway. 0.025, 0 I guess, but divided by 1, well that's still 0.025. Added to 1, do that first, and then raise it to my exponent. So it depends, you might have like this y to the x button, like I have, or you might have like a little arrow, something that looks like that as an exponent button on your calculator, so you might consider that one. So we're going to go to the power of 5. And then you'll notice that it's just a little bit bigger than 1, and you're going to get about 0.13 of a return on that. So times the 8,000 is your last step. I got about $9,000. $51.26. So notice that the question says how much interest is earned. Well, your interest is going to be your total value take away your principal. So $9,051.26, take away the $8,000. In the end, you made $1,051.26 in interest. just for letting your money sit there for 5 years. Right? So might be an extra trip to Mexico if you get a good deal. Alright, so a couple more examples I would like to do with you. We are going to turn to page 298. And I'm just going to look at number 8 for a moment there. It says, what is the difference in the amount of interest you will earn on $10,000 if you deposit at 3.75% per annum for 1 year if it is compounded annually compared to daily? So we're going to do 2 calculations here. So very quickly, I'm going to run through the very first one because when we're only compounding per annum, that means that my n is equal to 1 in that case. So compounded annually, I mean, n is equal to 1. But then in daily, your n is equal to 365. So go ahead, calculate. We've got $10,000. 1 plus my interest rate, 0.0375 divided by 1. And then it's 1. My term. My term is just still 1. Okay? So 1 times 1 if you really wanted to. So what I've got is 1 plus 0.0375 multiplied by the $10,000. I've got $10,375. If I scream really loud, it's my cat keeps jumping on my lap and digging his claws into my lap. So excuse me, I don't edit anything. And so that's the first one. So you're making $375 in interest. Now, the one where I'm calculating 365 times in a year, it's compounded that much. We're going to calculate that a little bit different. Got my 10,000. 1 plus same interest rate, 0.375. But I have to divide that by 365 days in the year. And my exponent is just 365. Technically times 1. And I'm going to show you how you want to calculate that there. So I'm going to go through 0.0375, but I need to divide first by 365. Push equals, I do that every time, plus 1 equals, now I want to bring it to that exponent. So any number of exponent, I'm not going to multiply a number by itself 365 times. Just, that would be ridiculous. So I get that. And now I can go ahead and times it by the $10,000. Oh, did I do too many? I did. Darn. There's no delete button on here. And try this again. Why is that? $10,000. And probably go to 10 cents. So the difference is going to be this take away this one. So actually ends up being like $7.10. So you make a little bit more when you compound it daily than if you compound it just yearly. All right. And one last concept I do want to just touch on here there is this thing called the Rule of 72. And what the Rule of 72 states is it's a quick and easy way to understand how long is it going to take to double your investment. So if you just take the number 72 and you divide it by whatever your interest rate is, but like don't change it to a decimal in this case. You're just like, if your interest rate's 4%, just going to go 72 divided by 4, and you can get that amount. So let's just take a look at what that's going to look like. If, for instance, I have $6,000 and we're wondering how long, if using the Rule of 72 to just give an estimate, how long is it going to take me to double that investment? So I want to know how long is it going to take to get to $12,000 at 4%. Well, I can just go 72 divided by 4, simple as that, and I get about 18. So it's going to take about 18 years to grow from $6,000 to $12,000. Now, it doesn't matter how much money I put in, it's just going to take 18 years to double that amount. And you could check this, doing a quick check, do the $6,000 times the 1 plus my interest rate divided by 1 to an exponent of 18 years. I could do that calculation. When I do that, I got $12,000, $154.90. So a little bit over 12,000. So it's a little bit over double 6,000. All right, so that is it. That is compound interest. If you have the ability to invest money, I highly suggest you do. Investments, it depends on the type of investment, what kind of interest rates you will receive. Interest rates are usually much lower on investments than they are on if you borrow money. The banks will charge much higher interest rates, which we'll talk about next unit. And the riskier the investment, the higher the interest rate does become. And so always talk to a financial advisor regarding which types of investments are right for you. But when you do, you're going to have a bit better understanding now of what they're talking about when they talk about these terms like compound and simple interest in the Rule of 72. Alright, so I'll see you on the next video.